Welcome to a new lesson of the course. In this lesson we are going to program the digital input. On the evaluation kit there is a blue push button that we can use for our programs. Its name is B1. We are going to write a program that turns on the LED LD2 when the push button B1 is pressed. This is the schematic of the evaluation kit. And this is the push button B1. The resistor R30 is a pull-up. It is connected to VDD in the power supply, that is 3.3 volts, so that when B1 is not pressed, the digital input PC13 will be high. When B1 is pressed, ground is connected to the digital input and the input is set to low level. Let's create the project P08 button B1 HAL from the software template. You can delete all the files starting with P01. I am creating the files app.gpio.c and .h from the files empty.c.h. We have to import app.gpio.c to the project. Let's change the occurrences of empty for app.gpio. Open the file app.gpio.h. Let's change the occurrences of empty for app.gpio. The directives, if not defined and defined, are to prevent the problem of double inclusion when dealing with the include directive. You can get further information on the web by googling for include guard. For the digital output, I define the macro to enable the clock and the constants to define the port A and the pin 5. This way we make our program easier to understand and modify. For the digital input, I define the macro to enable the clock and the constants to define the port C and the pin 13. As we are using the HAL, we have to include the file STM32F0 execs.hal.h. I am implementing the function app-gpio-config, where we configure the digital input and digital output pins. I like to add as prefix the file name where the function is implemented when the function is going to be used outside the file. In this case, we will use it in main.c. Declare a variable of type gpio init type dev. This is the piece of code to configure the digital output connected to the LED LD2. First, we enable the clock of the port with the macro defined in the file.h. The mode has to be digital output. For the field pin, we set the pin defined previously in the header file. With the function HAL GPIO init, the pin is initialized. This is the piece of code to configure the digital input connected to the push button B1. Let's enable the clock of the port with the macro defined in the header file. The field mode of the structure must be input. As we have seen previously on the schematic, there is already a pull-up resistor, so we don't need the pull-up pull-down resistors that the MCU has internally. For the field pin, we set the pin defined previously in the header file. With the function HAL GPIO init, the pin is initialized. In the header file, we add the prototype of the function to make it accessible from other files, simply by including this header file. Let's go to the file main.c. Let's include the file app-gpio.h to have access to the function app-gpio-config. Let's add the call to the function app-gpio-config to configure the pins. In the main loop, we read the state of the digital input with the function HAL GPIO read pin. If the return value is GPIO pin reset, that means that the push button B1 is pressed. If the button is pressed, we call the function HAL GPIO write pin with the third parameter GPIO pin set to turn on the LED. If the button is not pressed, we call the function HAL GPIO write pin with the third parameter GPIO pin reset to turn off the LED. We have finished the program. You can build, debug and test it.